For number 19, the answer is choice 2. And the reason being, if you read the question, it says, which of the following represents the sum, all of these are summation symbols, of a geometric sequence. And if you recall, a geometric sequence has a general formula of a sub n equals a sub 1 times your r to the n minus 1. And if you look at this, your a sub 1, let's do this in a different color so you can see, would be your 2. Your r would be your 3. And then your n minus 1 would be k minus 1. Okay, so that's the only logical one. If you look at the rest of them, they don't take this form down here of the general explicit formula for a geometric sequence. When reading the question, if you look at the second line down, it talks about compounded continuously. And automatically remember that when we see compounded continuously, we think a part. A equals PE to the RT. Now P is always your initial amount. In this case, if you read the question, it's saying Jackie's parents invested money at an interest rate of 6%. So that 6%, which is 0.06, is going to be your R. And it says they want to save this towards Jackie's college education. Now, let's read the second sentence. It says, how much money did the parents invest when Jackie started first grade to accumulate $20,000 after 12 years? So they're looking for that initial amount, which would be that P. And eventually what they did was they accumulated over time, in this case 12 years, $20,000. So that $20,000 is what they had after a period of 12 years. So that would be your A. We're looking for our initial amount. Again, our rate is 6%, which is 0.06, and time would be after 12 years. So what we're going to start by doing is we're going to just start simply by bringing down the left side, keeping that P and that E, and let's multiply 0.06 times 12. And when you do that, you're going to get 0.72. Oops, there we go. All right, now I'm trying to get the P by itself, so what I'm going to do is I'm just going to divide both sides of the equation by E to the 0.72 power. E to the 0.72 power over here as well, which will cancel out the right side and get that P by itself. Now remember, you have an E button in your calculator, so you're going to do 20,000 divided by, and then that's your second ln button, and then that'll bring up your E to the 0.72. So when you do that, now remember we are talking about money, so let's not forget the dollar sign, and remember dollar signs go in the beginning of the number. So you're going to have $9,735, and then we have 0.0451. Now, we're going to be rounding this. If you read the very last sentence, it says calculations have been rounded to the nearest penny. So that would be right here, 4. So we would make that a 5. So if you look at your choices, that would be choice 2. I think the easiest way to do this question is just to plug this equation into your calculator and your Y1. And then from there, you're going to do a zoom 6. So when I do that, I notice that my graph kind of looks like that. Okay, it does continue on to the left, and it does continue on to the right. However, let's take note of a couple of important things. I notice that it hits the x-axis at 4, so that would be my 0. Here's the big thing that we want to look at, is we want to notice, and you would probably want to go to your table, and you'll notice that what happens as we get closer to 6, your graph is going to asymptote there. And the way I know that is if you hit second table, you'll see at x equals 6, you're going to see an error. Okay, so what that means is that we have a vertical asymptote. So when we look at the domain, we notice that our x values, if we're talking about to the left here, right here, they go on forever and ever. So that would be negative infinity. However, right here, we get closer to 6, but we don't hit 6. So we're really going from negative infinity all the way, oops, maybe I can make a negative infinity sign, all the way up to 6, but I can't include the 6. And remember, with negative infinity, we never include that either because that goes on forever and ever. And the choice that best represents that would be choice 4. So number 22 is asking you to find the length of an arc. So remember, whenever we have the length of an arc, what we're going to do is we're going to use S equals R theta. All right, so we're looking for the length of the arc, which is represented by S. Now they do say a central angle on the unit circle. Remember, a unit is 1, so that would mean that our radius is going to be 1. And then they tell us that the central angle is 80. Remember that whenever you put in a value for theta, that always has to be in radians. So I'm going to take that 80 degrees, and remember we multiply that by pi over 180. Okay, well, 1 times anything is just itself. So basically what I've got here is I have S equals 80 pi over 180. And if I look at my 4 choices, that's not there. So I'm just going to take my calculator and I'm going to reduce 80 over 180. And when I do that, I will get, we can divide by 20. I'm going to get 4 pi over 9, which is choice 1. So here we want to find an equivalent expression. So I'm going to start by getting rid of my negative exponents. And the way that I'm going to do that is I'm going to take that numerator where it says a, b to the negative first, and I'm going to make that say a over b. Okay, if I have a negative 1 power, remember we can flip that down to the denominator. And that's still going to be plus 1. Then what I'm going to do is I'm going to do the same thing in the denominator. So I have 2 plus, and then in this case that would be 1 over a. So basically now I have a complex fraction. So what I'm going to do is I'm going to take these constants here and I'm going to put them over 1, and I'm going to look for a common denominator. So how about we look at the numerator here, and I can see that if I multiply both the numerator and the denominator by b, that will give me a common denominator. And then in the bottom here, in the denominator, I'm going to multiply both the top and the bottom by a, and that will also give me a common denominator. So now, if I look at what I've got here, I'm just going to follow this over to the right. And my new numerator is going to say a plus b. My stylus doesn't seem to want to work here. There we go. Over b. And then in the denominator, I'm going to have 2a plus 1. And that is going to be over a. All right, so now I have a complex fraction, and notice my numerator contains 1 term, and my denominator contains 1 term. So basically I have a plus b over b, and what I'm going to do is I'm going to keep change flip, And I'm going to take this denominator and I'm going to flip and multiply. So that's going to become a over 2a plus 1. Okay? So now, remember, what I'm really looking at now is just what I have here in this box. When we multiply fractions, just try to remember that we multiply across. So in other words, numerator with numerator and denominator with denominator. So let's go down here. I'm going to squeeze it in the bottom here. So in the numerator, I'm going to have a, and then a plus b. And then in the denominator, I'm going to have b, and then I'm going to have 2a plus 1. And if you look at your 4 choices, that is choice 2. So number 24 does not really require a lot of math work, but it does require a lot of reading and understanding. So for number 24, it says, after hearing complaints from the teachers, a principal wishes to conduct a survey to determine if he needs to take action regarding excessive cell phone usage in the school hallways between classes. Which of the following is the best method for the principal to gather reliable data pertaining to the amount of cell phone usage? Now, if you look at choice 1, it says select every 10th student from the hallways and ask his or her opinion on this issue. That's opinion-based, which is not the best way to gather reliable data, by asking opinions. So I would cross off choice 1. Number 2, let's look at choice 2. It says distribute a student questionnaire on this issue to each student seen in the hallways. Again, that's opinion-based, because if you give them a questionnaire and they're asking questions, they're going to give you your opinion, which again is not the best way to gather reliable data. So again, I would cross off choice 2. Then let's look at choice 3. It says ask each teacher to find the level of student cell phone usage in the hallways. So they're basically looking up and down the hallways and, you know, well, I think we have this many students. Again, an opinion-based type of thing. Cross off choice 3. So obviously, last resort, it's choice 4. Now let's just explain why. It says position observers in the hallways to count the number of students using cell phones. So they are physically counting. That is a reliable way to gather data. So that would be choice 4. Reading the question, you should see that we need to do z-scores here. So what we're going to start by doing is we're going to take the z-score for 84. So we'll do z-score 84. And remember, to find a z-score, it's going to be the value, which in this case is 84, minus the mean, which in this case is 92. And then we divide by the standard deviation. And they gave us the standard deviation, and they said that it was 9.3. All right, so then we work that out, and we should end up with negative 0.86. Now, they want to figure out what percent of students taking the test score between 84 and 101. So then we need to do the same thing again, but for 101. So we're going to do 101 minus 92, divide that by 9.3, throw that in your calculator, and you're going to get 0.97. Okay, so now remember, at this point, you're going to go to your calculator, and you're going to do normal, CDF, remember that's second, distribute, and then you're going to have your lower bound and your upper bound. So your lower bound is going to be negative 0.86, and your upper bound is going to be 0.97. And when you do that, you're going to get 0.6397. 0.08 because we're looking for the percentage of students between 84 and 101. We're using their Z-score values, and that will give us the percentage of students between 84 and 101. And then if we want to just flip this around a little bit, we're going to get 63.9% of the students would score between an 84 and 101. All right, so in this question, they're giving you f of x and they want you to write it as a product of linear factors. So what I did was I just went to my calculator and I plugged it into my y1. And this is what I get. So if I look at this, I can see where this graph is hitting the x-axis. So if I look first here, I can see that that is at x equals -1. Okay, this one over here, and you can go to your table to verify it. This one here, I'm going to just draw an arrow down if my stylus wants to work for me here. That's going to be x equals 2. And then the last one right there, sorry, that's not so great looking, but that's x equals 3. So those are my x-intercepts, where the graph hits the x-axis. So then if I was writing that, let's say I wanted to write f of x in another way, remember what we can do is we can change the signs of each of those x-intercepts. So for x equals -1, I could write that as x plus 1. And then instead of x equals 2, I can write x minus 2. And then instead of x equals 3, I can write x minus 3. And that, if you look at that, those are products of linear factors. Because if you look at this and this and this, they take that form of like y equals mx plus b. Okay, so then your answer is just going to be that. So number 27 is a three-way Venn diagram, and we really haven't done much of that, but it's not going to be that bad. So basically we have 3 dipping flavors: raspberry, peppermint, and mango. So I'm going to start by drawing 3 overlapping circles. Okay, now remember, Venn diagram is usually within our little rectangle here, so I'm going to go like that. All right, so let me start by saying we've got, let's say, raspberry here. It doesn't matter what order you put them in, and peppermint here. And then I'm going to put mango down here at the bottom. Okay. If you read the question, it says of the 150 customers surveyed, so that would be your total. So there were 150 customers. Throw that up at the top. 90 liked raspberry. Now remember, that means the entire circle is 90. So I'm going to throw that 90 on top of the raspberry. Then it says 65 liked peppermint, so I'm going to put 65 here. And lastly, 45 liked mango, so I'm going to throw 45 right down there. All right. Then it says 20 liked both raspberry and peppermint, but not mango. So that's your overlap between the raspberry and the peppermint, but not in the mango section. So that would have to be this top part right there. Okay. And then it says 5 liked both peppermint and mango, but not raspberry. So it's kind of the same idea. It can't be in the overlapping part there in the middle, so I'm going to put the 5 there. And then it also says 15 liked raspberry and mango, but not peppermint. So that's going to go out here. And 15 liked all 3. Now that's your overlap of all 3 in the center there. So that would be 15 smack dab in the middle. And 20 did not like any of the flavors. So remember, that's always your bottom right-hand corner. All right. Now, before we go any further and answer the question, let's fill out everything else that we do know. So if we look at the raspberry circle for a second, we see here, and I'm just going to highlight this, kind of outline it in red. If we have 15, 15, and 20, that together gives me 50. but the entire circle is 90, so that means I know that 40 people like raspberry only. Okay? Let's do the same thing with the peppermint. So let me highlight that in yellow. If you can see that. Okay, so I've got 20, 15, and 5. So when I add that up, that's 40. And the entire circle is 65. So then I know this outside part here is 25. Okay? All right, let's look at the mango. I'm going to do that one in blue. So the mangoes, well, we can add the 15, and the 5, which is going to give me 35, but the entire circle is 45, so I know that this outside section right there is 10. Okay? All right, so now if we look at that, now I think we're pretty safe to answer the question. It says, what is the probability that a customer liked mango given that he or she liked raspberry? What that means is, remember when it says given that he or she liked raspberry, that means you can only look at the raspberry circle. So that raspberry circle, look at it, it's in red. There's 90 people that you can choose from. Okay? That's your total. So given that he or she likes raspberry, look at just the raspberry circle. What's the total? That's 90. Now let's go back and reread the question one more time. It says, what is the probability that a customer liked mango? So in that red circle, what's the probability that they liked mango? And if you look, I'm going to circle it, here we go. That would be these two numbers here are part of the mango circle and part of the raspberry circle. So that together is 30. Okay, so your answer would be 30 over 90. I'd probably just go that extra step and reduce that. And that would be 1/3. Okay? 28 is asking for the two imaginary roots associated with this function. So I'm going to start by doing a little t-chart here. And I know that if I have x minus 5 as one of the factors, I can set that equal to 0 to find one of the roots. And then by doing that, I would add 5, and I would add 5, and then I would just get x equals 5. Now that's not an imaginary root. It is a root, but it's not imaginary, and that's not what they're looking for. That's a real root. So that will not be our answer. So I'm just going to cross that out. So then I'm going to go over here and I'm going to do the same thing. Now x squared plus 9 is not the difference of two perfect squares. So you can't do x plus 3 and x minus 3. So we're just going to set it equal to 0. We're going to subtract that 9 over. I'm going to get x squared equals negative 9. Now if I want to get x by itself, I'm going to have to take the square root. But remember, when you take the square root, I'm going to have to kind of squeeze this in a little bit here. I'll put it in red for you. I need a plus or minus in front. Okay? So that's going to give me x equals plus or minus the square root of negative 9, which we know is 3i. So we have two imaginary roots, and those imaginary roots are x equals 3i and x equals negative 3i. Whenever they ask a domain question, I like to just throw that equation and put that into my y1 and get a graph. This is what the graph of m of x looks like when you throw that into your y1, and I did a zoom 4. Now if you look at this, you can also go to your table to verify it, but you'll notice when you go to your table, when x is equal to 2, you're going to see error there. And if you look at the graph, you should be able to see here that I'm going to have an asymptote, a vertical asymptote here, and that's going to be at x equals 2. All right? So then if you look at 29 part A, it's asking you to determine the domain of the function of m of x. So basically, when you look at your domain, those are all your x values. So what you can do is you can just say your domain is going to be all real numbers except for x equals 2. And again, you can look at the picture and you can see that. Now, there's another issue going on here. So in addition to the fact that you can look and you can see that there's a vertical asymptote at x equals 2, the other thing I said before is if you go to your table, you will see that there's an error at x equals 2. However, arrow up or down a little bit, and you're going to see that there's also an error at x equals -5. So I'm going to add that into my little domain there. So the domain will be all real numbers except for x equals 2 and x equals -5. Okay, so that's one way you can do it. Now the other way that you also can look at this is, let's go back to the original m of x here. Okay, so just to explain where that -5 is coming from. Remember that you can't have a fraction that's undefined, which means the denominator can't equal 0. So if I take that denominator, which is x squared plus 3x minus 10, and I set that equal to 0, I'm going to see where it would be equal to 0, and those values I cannot have in my domain. Oops, that should be plus 3x in there. So if I do that, I'm going to get x plus 5, okay, and I'm going to get x minus 2. And when I set that equal to 0, you're going to see that I get x equals -5. There's where it came from. And x equals 2. And then you can see, obviously, there are the values that cannot be in the domain. All right? So that's for part A. Now for part B, it says find any asymptotes associated with m of x. Well, we already did one of them. It's right there. So one of the asymptotes is x equals 2. The other one that you need to see is if we follow this, and I'm going to underline or outline it, whatever. If you look, do you see that this is getting closer and closer and closer and closer to the x-axis, but it's not going to touch it? You can go to your table and you can look at all the values as they go towards -4, -5, -6, -7, -8. You'll see that the y values that correspond with those x values will get smaller and smaller, but they're not going to ever get to 0. So that is considered an asymptote. And so since the x-axis is considered an asymptote, its equation is y equals 0. So they want you to express this in simplest form. You have a calculator. It's got an I button. I would suggest you use it. That'd probably be the easiest way to go about this. So if you do I to the 5th in your calculator, you're going to get I. Minus 2. When you do I to the 4th in your calculator, you'll get 1. Plus 8, you're going to do I cubed in your calculator, you'll get -I. Then plus 3, you can do I squared in your calculator. Most of you have memorized that. That should be -1. Okay, and plus 11I. So now all I'm going to do is I'm going to combine like terms. So I have a positive 8i and a negative 8i, so those are going to cancel out. And I just have the 11i down at the end there. I'm going to put that second, and I'll explain why in a minute. Then, if we look here, I'll circle it in red. I've got a -2, and I've got a -3. So when we add those and combine those like terms, I'm going to end up with -5. Now that 11i is positive, so I'm going to go like that, and there's our answer. And the reason why I did that was I put it in a plus bi form. It doesn't say to, but it's just kind of good habit. So again, adding the two circles, the -2 times 1 and the 3 times the -1 gives me -5. The 8i's, the positive 8i and the negative 8i cancel each other out, and we're just left with the 11i. This one's asking you to prove. Now remember, when we do any kind of an algebraic proof, we want to leave one side alone and not do anything to it. So I am not going to touch the left-hand side of this equation. Now on the right-hand side, however, I am going to touch it. So I'm going to do distributing. So I'm going to distribute and distribute. So let's look and see what we get by doing that. So if I distribute that, I'm going to get a cubed. Then I'm going to get minus a squared b. And then lastly, I'm going to get a b squared. Now, I need to distribute the second term. So I need to distribute here, then here, and then there. And let's see what we end up getting. So when I do that, I'm going to get a positive a squared b. Then I'm going to get a negative ab squared. And lastly, I'm going to get a positive b cubed. All right, so let's look at what we have on the right-hand side. Well, I have a negative a squared b and a positive a squared b. So they're gone. Then I'm going to underline these two guys. Those are like terms, but they too are going to cancel themselves out because one's positive and one's negative. So when we look at what's left over here, again, let's always just bring one side down without manipulating it or changing it. All I have left is an a cubed and a b cubed. And now you see that the left side equals the right. Done. All right, so they want you to find the solutions, which essentially is finding x. So we need to find a common denominator here. So I'm going to start by putting that over 1, and I see that the common denominator would be 2x. So I'm going to multiply this by 2x and the denominator by 2x. This is going to look a little ugly, I'm sorry. And then the second fraction, I'm going to multiply by a 2 on the top and the bottom. And lastly, the last fraction, I'm going to multiply by x on the top and the bottom. All right, so now what I have here is I have 2x squared over 2x minus 6 over 2x equals x over 2x. Now we have an equation. We have common denominators. See you later, bye. All right, so now let's look at the numerator and let's just rearrange things a little bit. So let me just copy it down first. So I'm going to move this x here, and I'm going to move it over to the left-hand side. And in doing so, I'm going to change the sign of that. Okay, so we're just putting this in descending order there. Highest power to lowest power. There we go. All right, now, if we look at this, let's try to factor it. When we factor and we have a lead coefficient that's not a 1, remember we like to do our little rainbow. So what multiplies to negative 12 that would add to a negative 1? So remember we bring down our first term, and that would be a negative 4x and a positive 3x. And then we bring down our last term. Then we're going to group and group. And let's see what we have here. Well, I can take a 2x out of the first group, and that's going to leave me with x minus 2. I can take out a 3 out of the second group, and that's also going to leave me with x minus 2, which is a bonus. Right? All right, let's scoot on over this way. So that's going to give me 2x plus 3, and that's going to give me x minus 2, right? X minus 2, and we're going to set this equal to 0, and we are going to do our little t-chart, and we're going to solve. So on the right I have x equals 2, just change the sign. Over here on the left, I'm going to move that 3 over to the other side and make it negative, and then all I need to do is divide by 2. So x equals negative 3 halves. Oopsie. Let's make that really look like a negative. Sorry, that's a negative 3 halves. So our solutions are x equals negative 3 halves and x equals positive 2.